Yeah, hi my dears. Today I am going to teach you transport of carbon dioxide, the exchange of gases between the lungs and atmosphere, the exchange of gas between the blood and the tissue, okay, where carbon dioxide produced, where they can transport into the exit out in the exhalation. Okay. This is the process where the carbon dioxide started and where they can transfer into the exit out. We are going to discuss the exchange of gases. Okay. Today class all over about transport of carbon dioxide. Transport of carbon dioxide. Okay. What is carbon dioxide? It is the gas, high molecular weight gas, high molecular weight. It is most abundant on, like I will give you high molecular weight mean it can be occur on earth surface causes for global warming mean this gas where it is produced, where it is produced. This is the question, where it is, how it is transported into the atmosphere, this is the question here. What is the respiration role? Role for the release of CO₂ into atmosphere this is the question, and what is the role of lungs, okay, where what is the carbon dioxide gas, where it can be produced, it can be enter into the earth surface, where it is produced before that, and how it is transport. This is the question, okay, into the atmosphere. Okay. What is the respiration? What is the respiration? The role of the release into the lungs, atmosphere. What is the role of lungs? These are the questions coming from this session. Okay. We have to going to give the solution for these questions up to the NEET level. NEET it is not a only exam, it is the exam about the intellectuality, understanding, applied oriented base, the knowledge which is gained from the this standards, 12th standard, where the physiology topic is there, the carbon dioxide, okay, in the respiration. First, what is the respiration? We are going to discuss what is the respiration first. Okay. Yeah. How many of you in the online you can chart with me here? This is the chart bar. Here you can ask the questions relevant topic okay. Yes. Yeah, guys, if any doubts, you can ask, you can raise the question from here. Okay, I am going to deal here the transport of carbon dioxide. It is the gas which is high molecular weight, where it is produced from the respiration. What is the respiration? Where it is going to atmosphere, how it is going to atmosphere, what is the role of lungs, we are going to discuss today itself. Okay. Yeah, what is respiration? Okay, what is respiration? We are going to discuss now. Yeah, respiration nothing but it is relevant to the exchange of gases. Respiration nothing but it is the relevant of the exchange of gases. What are the gases? Okay, where it is exchange, where it is exchange, where to where, from where to where. There are two sides or their exchange of gases, mainly here CO₂, two places they can exchange. The place which is first from the tissue it is produced, tissue it produce into the blood, exchange. The first exchange part is here from the tissue to blood. Okay, from tissue to blood vessel it can be exchanged. CO₂. And next site where from the blood to lungs, this is the second site, this is the first site, this is the second site. Okay, from the blood to lungs they can exchange the CO₂ from here to here. From lungs to they can exit out atmosphere. Okay, this is the two sites the CO₂ can exchange. Okay, how it is exchanged? What are the factors involves? Yeah. What are the factors involves the exchange gas? Okay, what are the factors? First factor, if we see, that is the partial pressure. First factor is the partial pressure. Partial pressure, first factor is the partial pressure. Partial pressure. Yeah, partial pressure is what? It is the individual capability of the gas according to the Dalton theory. According to the Dalton theory, it is the indivisible capability of the gas in the mixture of gases. Okay. So, first site we have to see where the carbon dioxide produce, carbon dioxide produce, carbon dioxide here in the tissue. Actually first they produce in the tissue, we will going to discuss in the slide. It's carbon dioxide produced in the tissue this is the tissue guys, cells, okay, where the oxygen which is enter into the tissue, okay, from the blood, this is the blood, they can enter into the tissue, oxygen deliver here. This is the oxygen which is tissue utilize, they can break down the food particle and release carbon dioxide. This is called cellular respiration. Cellular respiration. If it is produced carbon dioxide here, this CO₂ where it is produced in the tissue, that can be released through the vein, they enter into the blood, okay. After enter into the blood, this is the vein, the oxygenated blood, this is the artery, they can deliver oxygen, the vein they can catch the carbon dioxide which is produced in the tissue in the metabolic activity, action, CO₂ produce, CO₂ they enter into the blood and they enter into the vein, vena cava, this is the blood vessel, they can catch the deoxygenated blood. Okay. This vena cava, they can carry the carbon dioxide into heart, okay. Yes, this deoxygenated blood from the ventricle, right ventricle, they can reach through this artery called pulmonary artery, they can reach lungs, finally. From the pulmonary artery, they can reach lungs. Deoxygenated blood converted into the oxygenated blood. This is the pulmonary vein. They can carry oxygen into the right part of the heart. This is the transport of carbon dioxide. Okay. This is the transport of CO₂. This is the transport of the CO₂. Okay. So, here Yeah, this is the transport of carbon dioxide. So, this is the pathway of transport of carbon dioxide, where it is the tissue produce from the oxygen they can burn and produce CO₂ as a waste product, CO₂ as a waste product, which is they can deliver into the blood. That is the blood converted into the deoxygenated, that can be blood vessel they can carry into the heart, from the heart they can reach lungs. This is the pathway the carbon dioxide where they can transport. What are the factors involved in this action, this pathway, the carbon dioxide transport? There is it is not as much as simple, there is a chemical nature, chemical action is going to take place in this transport of carbon dioxide. Okay? We are going to discuss about it. Yeah. So, as I told you, like, yeah, where it is from the, this is like artery, they can, the pulmonary vein, they can reach CO₂. This is the exchange of gases of the respiration, where the carbon dioxide exit from the blood vessel into the alveolus. From the alveolus, the oxygen enter into the blood. This is the oxygenated blood. And this is the deoxygenated blood. Deoxygenated blood nothing but they can carry CO₂, carbon dioxide. This is carry oxygen. Okay. Finally, they can reach alveolus. Alveolus from they can exit out through the breathing. Okay. This is the simple scenario. We are going to discuss the factors involved in the like carbon dioxide. Yes. First, alveoli are the primary site of the exchange of gases. Primary site of the exchange of gases, either O2 or CO₂. Exchange of gases are going to take place. This is the one site, site 1. Okay. Yeah. Exchange of gases also occur between the blood vessel and the tissue. This is also O2 and CO₂ exchange, site 2. Site 2. Okay. Yeah. O2 and CO₂ are the exchange in these sites by simple diffusion, mainly based on pressure or concentrate gradient. This is the process only, the diffusion. Diffusion, the process. They can ask you, okay, which is the process. Okay, diffusion, mainly like factors are based on partial pressure or concentrate gradient. Okay, this is keyword. Solubility of the gases as well as thickness of the membrane involved in the diffusion are also some important factors in the factors that can be effect on rate of diffusion. Rate of diffusion mainly focus like depend on solubility of the gases. This is important, previous year question. Solubility, solubility of the gas, solubility of the gas and thickness of the membrane. Thickness of the membrane. These two factors mainly, the diffusion is mainly depend on the solubility, nature and thickness of the like membrane. Okay, what is membrane we will going to discuss. Yeah, the pressure concentration contributed by individual gas in a mixture of gases called partial pressure, and it is represented PO2 is for the oxygen and PCO2 is for the carbon dioxide for the this mainly depend on the mixture of gases called partial pressure. The pressure contributed an individual gas in a mixture of gases. Mixture of gases mean in the atmosphere there are different type of gases. Okay? Yeah, especially this is the NCERT diagram, the partial pressure, okay, where the respiratory gas oxygen and CO2, two gases, atmospheric air which is 159 mmHg and carbon dioxide which is 0.3 mmHg. Okay? This is mmHg. Okay? Yeah, alveoli which is 104 and carbon dioxide mean deoxygenated which is 40. Okay? The blood I will going to show you in a diagrammatic method. Okay? Atmosphere, where oxygen is 159 mmHg and carbon dioxide is like 0.3 mmHg. If it is reach lungs, these gases they can reach lungs. They can reach lungs. Oxygen is 104 mmHg. Because of oxygen they can produce in the atmosphere, they can reach lungs. From the lungs they can reach blood vessel, blood. This oxygen they can reach blood vessel. In the blood, how much the partial pressure of the it is oxygenated blood. Oxygenated blood about 95 mmHg. This blood they can carry oxygen into the different tissues. This blood they can carry oxygen into different kind of tissues. All over part of the body like tissues, the oxygen can reach. Oxygen can reach. Tissue can utilize the oxygen. This is the tissue. Oxygen release site. This is the oxygen binding site, lungs, with the blood. okay, oxygen binding site and oxygen releasing site. This oxygen tissue utilize oxygen utilizes oxygen and produce carbon dioxide partial pressure, solubility of gas and diffusion membrane. Yeah, sir, screen is blur. Yeah, now are you okay, guys? Yes. Yeah, carbon dioxide which is produced in the tissue, the CO2 where it is produced, the CO2 where it is produced, the partial pressure of CO2 it is 45 mmHg in the tissue. They can enter into the blood here 45 mmHg in the tissue of CO2. They can enter into the blood. This is the blood vessel. CO2 enter. This blood vessel has 45 mmHg. Hg of the CO2, and oxygen itself here in this blood as 40 mmHg. This is NEET question. Hg of oxygen. Guys, deoxygenated blood has oxygen or not? If it is deoxygenated blood, also oxygen is there, how much percentage? This is the question. Deoxygenated blood does have contain oxygen? This is the question. If it is contain, if it is also carries oxygen, how much percentage? How much percentage? Either 25%, A, B 50%, C 75%, D 10%. How much percent oxygen carries the deoxygenated blood? Assume it is 100% of any gases. The percentage of oxygen in the deoxygenated blood, how much? This is the NEET question. Okay? From here, it can be 45 mmHg, which is CO2 carry deoxygenated blood, and oxygenated blood also carry 40 with the 40 mmHg in the deoxygenated blood. Okay? In the tissue, they can reach lungs. Finally, they can, deoxygenated blood also reach lungs. They can carry oxygen and as well carbon dioxide. They can carry oxygen and carbon dioxide. Carbon dioxide which is 45 mmHg, right? 45 or 95? Deoxygenated blood. 45. Yes, good. Oxygen which is 40 mmHg. Oxygen, okay. Deoxygenated blood they can carry 45 mmHg carbon dioxide, oxygen 40 mmHg into the lungs. From the lungs, here the partial pressure is high, okay. Partial pressure of oxygen is high as compared with carbon dioxide in the lungs. So, it is the lungs release side of the CO₂ due to partial pressure the tissue is the binding site for CO₂. Once it is breathed, exit out, it can be reached as 0.3% in the atmosphere release. Okay. Yeah, if it is coming to this, just look into this. Yeah, this site where the oxygen is bind, partial pressure of oxygen, this site is high. Oxygen is high. Is it right? Good. High. Here, partial pressure of CO₂ is high. High. For the exchange of gases, this is the scenario. This is the question for you today, guys. You have to answer it. How much percentage they can carry the oxygen in the deoxygenated blood? Oxygen carry, it is also carries oxygen where? The deoxygenated blood. Deoxygenated blood, they can carry how much percentage of oxygen here? This is the question for you guys. You guys answer it, okay? Yeah, if any challenges, let me know in the comment section, okay? Thank you. Yes, I hope this is the clear. Yeah, here just look into this, the partial pressure of mmHg, oxygen and carbon dioxide different in the parts of involved in the diffusion as comparison those in the atmosphere. Atmospheric air which is 159 mmHg, that is carbon dioxide 0.3 mmHg. In the alveoli which is like oxygen 104 mmHg, this carbon dioxide 40 mmHg. In the blood which is deoxygenated blood, oxygen which is 40 mmHg, carbon dioxide 45 mmHg. And if the oxygenated blood which is 95 mmHg of the oxygen and 40 mmHg is the carbon dioxide, in the tissue where oxygen is 40 mmHg and carbon dioxide is 45 mmHg. This is the differentiation in the different part of the body. The oxygen and carbon dioxide where they are supposed to be carried out through this partial pressure. Okay? Yes. And yeah, this is the like inspiration and expired hair which is alveolus, where there is a like high amount of gas which is directly enter into the blood, because of they can easily bind with the hemoglobin, binds with hemoglobin binding site of oxygen due to partial pressure. This is the oxygenated blood, which is the systematic arteries, they can carry into the tissue, which is systematic pathway, and this is the pulmonary pathway, okay. Systematic pathway, mainly the oxygen binds. These kind of words also they can ask you. Okay? Yeah, where the oxygen deliver, and the pulmonary pathway mean pulmonary circulation, which is carbon dioxide deliver. Okay? In the systematic pathway, systematic circulation where the oxygen deliver, in the pulmonary pathway, pulmonary circulation where the CO₂ is delivered. They can ask you in these names also, these terms also they can use in the exam for consumption of your time. Okay? Yes, here the partial pressure differentiation in the oxygenated blood. If come to the tissue where the CO₂ produce, CO₂ partial pressure and oxygen partial pressure differentiation here into the pulmonary circulation, the pulmonary artery, they can carry deoxygenated blood as the amount of carbon dioxide is partial pressure is high into the lungs. Finally, there is a expired air which is high amount of CO₂, and this is high amount of O2. This is the diagram which is shown in the NCERT book, okay, as it is. Yeah. Yeah, I am going to read these lines from the NCERT. These are exclusive I did take directly from the NCERT, which is important for the NEET exam. They can ask you from these lines. The concentration gradient for the oxygen from alveolus to the blood and blood to the tissue. Similarly, the gradient pressure for the CO₂ opposite direction, the from the tissue to blood and blood to alveoli. Same. Okay, where the alveolus oxygen takes place, where the carbon dioxide takes place in the tissue similarly. Okay? Yes. The solubility of the carbon dioxide, this is important for NEET. This is the important point for NEET, guys, focus it. Yeah, what this statement says, O2 and CO₂ are the gas, these are the gases, gases can dissolve in the solutes, okay, can dissolve in the solution, okay. The ratio of between those, the solution rate mean dissolve nature is 20 to 25% higher of the carbon dioxide than oxygen. Because of you have to find there is a experiment, hydrilla experiment in the photosynthesis, there is a release of oxygen, right? There is a experiment, oxygen they can release in the bubble nature. Bubble nature means that unlikely to dissolve in the water, oxygen mainly. Okay? The ratio as compared with carbon dioxide and oxygen, carbon dioxide dissolved nature is 20 to 25% is higher than oxygen. Okay? 20 to 25% higher than oxygen, they can dissolve in the plasma directly. Plasma nothing but water in the blood, right? So, yeah, as I say, 3% of oxygen dissolve in the plasma, 7% of carbon dioxide dissolve in the plasma. In the plasma, oxygen 3% dissolve, 7% carbon dioxide dissolve. Okay? Yes. The amount of that can be diffused through the diffusion membrane as per unit. As per unit, the partial pressure is how much I compare to the CO2. As compared with the dissolved ratio, they can easily diffuse through the membrane. Okay? Yes. I hope you guys understand this. Yeah. Yeah. The diffusion membrane is made up of 3 major layers. Yeah, made up of 3 major layers. Okay? What are the 3 major layers? As already I told you, again I will have to tell you. Okay? This is alveolus, oxygen enter, and this is the blood vessel, proximally the blood okay. CO2 they can produce, and this oxygen they can diffuse into the blood vessel. CO2 also diffuse into the alveolus. Okay? These are the site they can diffuse. Yeah, this is the wall of alveolus is made up of with squamous epithelial tissue. Squamous epithelial tissue, and blood vessel also a layer which is endothelial tissue. Endothelial tissues nothing but modified squamous epithelial tissue. Okay. The function of epithelial tissues, are 1 located in the diffusion boundaries, they can diffuse, involve in the diffusion, and located in the filtration boundaries, involve in the filtration. These are the two functions about squamous epithelial tissue. They may confuse you. Squamous epithelial tissues are involved in the other functions like absorption, secretions. So, these two main functions of the squamous epithelial tissue, they can involve in the diffusion and filtration. Diffusion and filtration. Okay? Yeah. Here, the endothelial tissue, endothelial cells, which is modified squamous epithelial tissue in the blood vessel. Okay? So, this is the site 1, this is the site 2, sorry, part 2, part 1. Okay? They can cross 3 membrane. This is 1 membrane, this is 2 membrane, third one is basement membrane. Okay? Third one is base membrane between the epithelial tissue, nothing but they are supported by a base membrane. This is the third membrane, base membrane. Base membrane. Base membrane is the cellular or acellular? This is the question. Base membrane is the acellular membrane. Base membrane is the acellular membrane which is non-vascularized, no vascularized, no vascularized. No vascularized. Does it mean no blood enter, no blood circulation? No blood circulation. Okay? This is about, they can cross 3 layers, which is one squamous epithelial tissue which is in the alveolus wall, and there is a endothelial tissue which is in the blood vessel wall, and there is a base membrane between them. Okay? The blood, like either carbon dioxide, they can transport into the alveolus from the deoxygenated blood, and there is oxygen which is enter into the blood. This part is deoxygenated blood, and this is oxygenated blood. Oxygenated blood. Okay? Which is enter oxygen into the blood is oxygenated blood, which is carbon dioxide carry, the part is deoxygenated blood. This is all over the 3 membranes they can cross. Okay? Yes, basement membrane which is the non-vascularized acellular membrane. Okay? There is no blood supply. There is no blood supply in the base membrane. Okay? Yeah. Yeah, this is the NCERT diagram they given here. I am going to show you.